Hello everyone, my name is Divya Bharti Mahindran, first year student from Microbiology and Molecular Genetics course.
Hi everyone, my name is Muhammad Karan Zulkifli. I am from student of Microbiology and Genetics.
Hello guys, my name is Kanalakshmi Govindan and I'm a first year student in Microbiology and Molecular Genetics.
Assalamualaikum, my name is Emrahan Mabaraza and I am from Institute Science Med.
Hi everyone, I'm Kirtana Sagardes and I'm a year 1 semester 2 microbiology and genetics student. Thank you.
Let's have a look at some basic information regarding biosensors. Biosensor is a short form of biological sensor. This device interacts with the analyte being tested and measures the biological or chemical reactions of it by generating signals proportional to the concentration of the analyte. To know more about biosensors, first we have to learn its history. It was 1906 when a British scientist demonstrated in one of his experiments that the concentration of an acid in a liquid medium is proportional to the electric potential arise in the fluid. Further experiments led to the discovery of pH concept later in 1909 by Søren Peter, a Danish chemist. In 1956, after a lot of research, Leland C. Clark Jr. invented a so-called true biosensor which was used for oxygen detection in blood, water and other liquid samples. The same American biochemist then demonstrated how to do an amperometry enzyme electrode for glucose detection in 1962. In 1969, Gilbert and Montalvo, Russian scientists, were able to develop biosensors that could detect urea content in soil sample. In 1975, Yellow Springs Instruments produced first ever commercial biosensor. It was a pen-shaped single-use electrode to detect glucose content in the human bloodstream. Since then, a lot of developments have been made in terms of creating more efficient biosensors. Next, let's have a look at the components in a typical biosensor. Firstly, we have analyte. Analyte is the substance of interest that needs detection. For instance, glucose in blood is an analyte. Secondly, a biosensor has bioreceptor. Bioreceptor is a molecule that specifically recognizes the analyte. Enzymes, DNA and antibodies are some of the examples of bioreceptors. When bioreceptor recognizes an analyte, it will emit a signal, and scientists call the process as biorecognition. This biorecognition event must be converted into a measurable signal, and transducer does the job in a biosensor. Every biosensor must have electronics. These electronics processes the transduced signal and prepares it for display. And lastly, display is a must-have component in a biosensor. This is because display consists of user interpretation system that generates a number of curves understandable by the user. There are various types of biosensors developed over a period of time. Two main classes of biosensors are biological element biosensors and transducing method biosensors. Biological element biosensors include antibody, DNA, enzyme, biomimetic, and phage. Transducing method biosensors can be further classified into three categories, and they are known as optical, electrochemical, and mass-based. As for the last part in introduction, let's study the benefits of biosensors. Biosensors have high specificity. Thus, we can expect a very accurate diagnosis from a biosensor. A biosensor helps save time since the response time is relatively fast. Other than that, biosensors are smaller in size and portable compared to other types of sensors out there. Therefore, it is easier to transport them and insert anywhere as we like.
So next slide, Malaysia is currently lacking behind in this aspect because the technology is still new for the Malaysian expertise. To this extent, the relatively small numbers of application of it that have made it through the industrial application represent revolutionary rather than evolutionary advances. Therefore, there is a need of research to look into the management aspects of the nanotechnology biosensors in order to effectively and efficiently manage the future directions of the technology. For now, Malaysia had been using biosensors for a lot of different occasions, which is important. Okay, so for next slide, biosensors to detect severe acute respiratory syndrome, coronavirus 2. RT-PCR is the gold standard test for diagnosing COVID-19. Although it is highly accurate, this lab test requires highly trained personnel and the turnaround time is long. Here we review three types of recently developed biosensors for SARS-CoV-2 detection. You can see all that. The accuracies of these sensors need to be improved before they could be translated into POC devices for commercial use. To increase the true positive detection rate, we suggest two-dimensional materials, nanomaterials. What these materials help to do is that it could be used to modify the sensor surface to increase the sensitivity of the sensor. Okay, for next slide, simple structure fluidic based memory stir for immunosensing of NS1 protein application. NS1 protein is becoming a commonplace biomarker for the diagnostic of early detection of dengue. In this study, we sought to use a label-free approach of detecting NS1 protein by harnessing fluidic-based memory stir sensor. Imaging with that evince the successful immobilization of the antibody and the subsequent capture of the NS1 protein by immobilized antibody. So the detection limit actualized by the developed sensor was 52 nm, and the diameter of 2 mm gives the most optimal measurement. The developed sensor demonstrated an immense potential towards the development of label-free diagnostic of early dengue infection.
Now, let's take a look on the role of biosensor in sustainable development. Biosensors have a wide range of applications that aim to improve the quality of life. Firstly, biosensors play a huge role in human health. One of widely used biosensors in clinical applications is glucose biosensor for diagnosis of diabetes mellitus. Other than that, there are biosensors for estimation of cholesterol, which can provide portable and multiple protein detection platforms, allowing rapid diagnosis and treatment of cardiac diseases. Biosensor-based detection is used for cancer clinical testings too, since it's faster, more user-friendly, less expensive, and less technically demanding. More biosensors are being used in medical field to diagnose infectious diseases, such as urinary tract infection. Biosensors also have wide use in environmental monitoring. Bacteria biosensors are used for the determination of heavy metals, which are dangerous environmental contaminants. They are biosensors to determine BOD, which is an important parameter used in the estimation of amount of biodegradable organic pollutant in water. Presence of pathogens in waste, untreated and treated water is a huge environmental problem concerning public health. Biosensors were developed to identify the pollutants by microorganisms. These are the few commercial biosensor industry for environmental monitoring and management. Biosensor technology has become practical and advantageous for disease detection. One of it is the recently acquired by many, the biosensor for COVID-19 diagnosis. There are many diagnosis tests that were developed during this COVID-19 outbreak are being used widely. A biosensor also has been developed to detect the deadly HIV virus within a week after infections, instead of previously used method, which need 3 to 4 weeks. These are the few of developed biosensors for detecting bacterial and viral pathogens in the human body. Biosensors are useful in food industry too. Biosensors are used for the detection of pathogens in food. Presence of E. coli in vegetables can be measured by detecting variation in pH caused by the ammonia. In dairy industry, enzymatic biosensors are used to quantify the 3 organophosphate pesticides in milk. Furthermore, biosensors are being employed to general toxicity and specific toxic metals in food due to their capability to react with the only hazardous fractions of metals ion. Biosensors are also used to detect pesticides in food. They are a type of biosensor that is used to detect pesticides in wine and orange juice with the help of bacteria-based bioassays. This slide shows few commercial biosensors that are used in food industry. Now I will pass to the next presenter.
Greetings all. Well, as have been explained by Kanaka before, the roles and the significance of biosensors are extremely important as biosensors are employed in various applications. However, there is an exception to this. Now let me turn your attention to the challenges that exist in developing biosensors. Despite the significant progress in prevention, diagnosis and treatment in the last century, infectious diseases have remained as a significant global health problem. Major challenge for the management of this disease is the ease of rapid disease dissemination. Therefore, for many infectious diseases, rapid diagnosis and timely initiation of effective treatment are the critical criteria for the patient health outcome. Not only that, in vitro diagnosis for the infectious diseases is a time-consuming process too, and this needs facilities, experienced workers, and large equipments. And this is why the system integration for the diagnosis of the infectious diseases remains the most critical challenge for the biosensor technology to transfer from laboratories into the clinics. Well, moving on. Biosensors are widely used to detect the presence of pathogens, but their application is subjected to several limitations, including detection limit and detection time. Firstly, detection time brings its own challenges when designing a biosensor system. For example, finding a suitable technology while maintaining the highest sensitivity and also the specificity. And in addition to this, The detection limit is another important parameter to keep in mind. This is the minimum amount of the biological entity that can be detected. In this case, the detection limit is often compromised by the detection time in the development of rapid biosensors, and this is why a biosensor is only useful if its detection time and limit is lower than the threshold limit of the pathogen in question. Well, the development of biosensors becomes questionable when there's a financial liability that's hanging in the air that causes economic issues. In fact, the balance between the market potential and the financial hurdles will determine the future evolution of biosensor markets. A few technical problems are actually slowing down the commercialization of biosensors, and this includes selectivity, reproducibility, and also reliability. These types of considerations not only delay new product launches but also prevent the large-scale production. And the time and resources required to bring biosensor to the market hinders the venture capitalists as well as possible biosensor entrepreneurs who are actually interested in developing the biosensor system in our country. Well, moving on, now we were focusing on the economic issues. Yet, as a person in scientific community, we must not overlook the ethical issues that we're facing in developing biosensor. Various international and national bodies with the authority have already developed some general regulatory tools, but there's a limited supply of such instruments specifically for biosensors for different countries. The right to enjoy the benefits of scientific progress and its application is just as most other human rights in international law. There is a still great divide in the equal participation in access and also the use of the scientific technology. In general, many people from developing countries do not benefit from the scientific and also the technological advancements because only a fraction of knowledge and technology is available or accessible in these countries. And this challenges the development of biosensor technology as well as other technologies to thrive equally and ethically in all parts of the world. As we have discussed on the challenges in developing biosensors detailing, now I'm passing the presentation to Muhammad Khairul Adli.
We will have the immunosensor technology, because by the immunosensor technology, we can detect our immune system response, whether our immune system produce a great immune system or great macrophage or white cells and so on, whether the reaction is normal or not, and then our immune system can fight the viruses, the pathogen, the bacteria. So by immunosensor, we can detect our own problem of our immune system in our body. So if we implemented this immunosensor in all the hospitals, the clinics, and the medical staff, the doctor, we have a very easily way to observe the disease of the patient. And of course, it will give a great diagnosis. What is food technology? So in the production of the food, we must be product a very huge amount, or the food must be equivalent to our people's right. So in order to do that, all the staff or the workers, the staff or the food technologist workers must practice a very hygienic process, because one non-aseptic technique in handling the food productions, it will cause the food contaminant. So the food will be rotten and we will carry the bacteria on it and will be released to the people. It is very dangerous act or very dangerous event that we cannot even think about it. However, it has happened in Malaysia, where there is one jam of canned food, or I think it's a peanut butter, where the research or scientists found that there were salmonella in it. So if we have the biosensor, we can detect easily the contaminated food. We can detect the bacteria, the viruses, the pathogen, just by using the X-ray station in high light beam into the foods. And then if the food was contaminated, we will not release to the people. And then for the last one is for the environment. What can the biosensor do with our environment? So I am suggesting that the government must have this biosensor, water quality biosensor. Since the most problematic words in Malaysia is the problematic issue in Malaysia is about the water pollution. If you know, in Selangor we have been facing a water shortage because of the water sewage treatment has been polluted by something that we didn't know, maybe because of the odor pollution, or there's a contaminant, or there's a very bacteria on the sewage treatment or on the water on the river. So when the government has this biosensor, they can detect easily the toxins in the water in the early stage of the pollution. So the government can clear the water quickly, and then we will not facing any water shortage. So this is a very good example.
This is the list of references that we use to get all the verified information from. We would like to express our sincere gratitude to our lecturer for all his help in finishing this assignment. With that, I end our presentation. Thank you so much for watching.